What if I told you that most people never use their full strength, and the biggest limit isn't their muscles, but their brain? What if one of the biggest fitness beliefs in the world is only half true? What if the strongest person in the room isn't always the one with the biggest muscles? I've been fascinated by human biology for as long as I can remember, and every now and then I stumble across a question that completely changes the way I see the human body. This was one of those questions. Think about it, we've all seen it happen. A person walks into a gym with arms that look carved from stone, shoulders stretching the seams of their shirt, and muscles that seem to announce strength before they ever touch a weight. Then someone else steps forward, smaller, less impressive at first glance, almost ordinary. Yet somehow, when the barbell leaves the ground, it's the second person who lifts more. The first time I noticed this, it genuinely bothered me, because it didn't make sense. If muscles create force, then bigger muscles should always mean greater strength, right? That assumption feels so obvious that most of us never question it. We simply accept it as truth. But biology has a habit of hiding its most fascinating secrets beneath things that appear obvious. The deeper I looked into the science of strength, the more I realized that what we see on the outside tells only a small part of the story. Underneath every movement you make, every object you lift, every staircase you climb, and every challenge your body overcomes, there is an invisible system at work. A system so powerful that it can make one person dramatically stronger than another without adding much visible muscle at all. And once I understood this hidden mechanism, I could never look at strength the same way again. In fact, it made me realize that most people are training their muscles while barely understanding the biological machinery that actually allows those muscles to express their full potential. So today, I want to explore this mystery with you, not just how muscles grow bigger, but what truly makes a human being strong. Because the answer leads us far beyond muscle size, into one of the most remarkable systems in the human body, and it may completely change the way you think about strength forever. The moment I realized that strength and muscle size are not the same thing, another question immediately appeared in my mind. If bigger muscles aren't the whole answer, then what exactly are our muscles adapting to when we train? One of the things I love most about biology is that the human body is never random. Every adaptation exists for a reason. The body is constantly asking a simple question. What challenge am I facing most often? Then it quietly begins reshaping itself to meet that challenge more efficiently. What surprised me was discovering that muscles can adapt in very different ways depending on the type of demand we place on them. Imagine a marathon runner moving steadily mile after mile. Their muscles are not producing enormous amounts of force with each stride. Instead, they are performing thousands of contractions over an extended period of time. The challenge is endurance. The body responds by becoming better at resisting fatigue and sustaining movement. Now picture a bodybuilder. The goal is completely different. Here, the body is being pushed toward growth. Muscle fibers gradually become larger, increasing the overall size of the muscle. This adaptation is known as hypertrophy, and it represents one of the most visible transformations the human body can undergo. But then, there is a third adaptation that fascinates me even more: strength. Unlike endurance, which prioritizes sustainability, or hypertrophy, which prioritizes size, strength prioritizes force. It is the body's ability to generate the greatest amount of power possible in a single effort. The interesting part is that these adaptations are not isolated categories. They exist on a spectrum. At one end lies muscular endurance, typically trained with lighter loads and higher repetitions. In the middle sits hypertrophy, where moderate loads stimulate muscle growth, and at the far end lies strength, where heavy loads and low repetitions challenge the body to produce maximum force. For years, I assumed that moving from endurance to hypertrophy to strength was simply a matter of lifting heavier weights. But the deeper I looked, the more I realized something remarkable. While endurance primarily changes how long muscles can work, and hypertrophy changes how large muscles become, strength begins to change something far less visible. Something hidden beneath the muscle itself, and that hidden system may be the real reason some people become astonishingly strong. I still remember the moment I first learned that strength is not simply a muscle adaptation, it's also a nervous system adaptation. Honestly, it felt like discovering a secret layer of human biology that most people never think about. When we decide to lift something heavy, it feels as though the muscles are doing all the work. After all, they're the part we can see, they're the part that burns, grows, and gets stronger. But the more I studied how movement actually happens, the more I realized that muscles are not the true starting point. Everything begins in the brain. Before a muscle fiber contracts, before a weight leaves the ground, a signal must travel from the motor regions of the brain down through the spinal cord and into specialized nerve cells called motor neurons. These neurons eventually connect to muscle fibers through tiny communication sites known as neuromuscular junctions. What fascinates me is that the body organizes these connections into groups called motor units. A motor unit consists of a single motor neuron and all the muscle fibers it controls. Some motor units control only a few fibers and are responsible for precise movements. Others control hundreds or even thousands of fibers and are built for producing tremendous force. But here's the detail that completely changed how I think about strength. Your body does not automatically use every motor unit available. In fact, most untrained people cannot voluntarily access all of the force their muscles are capable of producing. Studies suggest that many individuals recruit only about 70 to 85% of their available motor units during maximum effort. The rest remain in reserve. At first, that sounds strange. Why would the body hold back? The answer is protection. Your nervous system is constantly trying to prevent injury. It acts like a cautious guardian, limiting force output to protect joints, tendons, ligaments, and other tissues from damage. Strength training gradually changes that relationship. With repeated exposure to heavy loads, the nervous system becomes more willing to recruit additional motor units, activate them faster, and coordinate them more efficiently. In a sense, the body learns trust. And that's what amazes me most. Some of the earliest gains in strength don't come from building bigger muscles at all. They come from learning how to better access the strength that was already there, quietly waiting beneath the surface. And yet, the more I learned about the nervous system's role in strength, the more I found myself wondering what happens to that system and the muscles it controls as we grow older. This is where the story of strength becomes much bigger than fitness. For a long time, I thought strength training was mostly about athletic performance. Maybe lifting heavier weights, maybe building a stronger physique. But the deeper I explored human biology, the more I realized that strength may be one of the most important predictors of how well we age. The reason lies within the muscle fibers themselves. Not all muscle fibers are created for the same purpose. Some are built for endurance, allowing us to walk, cycle, or remain active for long periods without becoming exhausted. Others are designed for power. These are the fast-twitch fibers, the fibers capable of producing high levels of force in a very short amount of time. What fascinates me is that our bodies are incredibly selective about when they use them. During ordinary daily activities, we rely mostly on slower, more fatigue-resistant fibers. They handle the majority of the work required for routine movement. The powerful fast-twitch fibers are often kept in reserve until the body faces a greater challenge, such as sprinting, jumping, or lifting heavy loads. In many ways, they are the body's emergency reserve of strength. Unfortunately, biology comes with a trade-off. As we age, these powerful fibers are often the first to decline, and when I first learned that, it completely changed how I viewed the aging process. Because losing fast-twitch fibers isn't just about becoming weaker, it's about losing capabilities that many of us take for granted. The ability to catch yourself when you trip, the ability to quickly step out of danger, the ability to rise from the floor without assistance, the ability to remain independent. When we see older adults struggling with balance, mobility, or simple physical tasks, we're often witnessing the consequences of years spent underusing the very fibers designed to produce force and power. That's why I no longer see strength training as an activity reserved for athletes or gym enthusiasts. I see it as a biological strategy for protecting the future. Every time we challenge those powerful muscle fibers, we're sending a message to the body that they are still needed. And perhaps one of the most remarkable things about strength training is that it allows us to invest in abilities we may not fully appreciate until decades later. And perhaps that's the most encouraging part of this entire story. Preserving strength may require far less than most people imagine. One of the biggest surprises I encountered while studying the science of strength was learning that you don't need to spend countless hours in a gym to benefit from it. Modern fitness culture often creates the impression that meaningful strength requires extreme dedication, endless workouts, and a lifestyle built around exercise. But biology tells a much more practical story. The human body responds to consistent signals, not constant punishment. Research suggests that maintaining strength can often be achieved with only a few challenging sets per muscle group each week. Even modest amounts of well-structured strength training can preserve and improve the adaptations we've discussed throughout this journey. For those seeking greater progress, a slightly higher training volume can accelerate improvements, but the principle remains the same. Consistency matters more than perfection. I find that idea incredibly powerful because it makes strength accessible. You don't need to be a competitive athlete. You don't need to dedicate your life to lifting weights. You simply need to give your body a reason to keep the systems of strength alive. For some people, that may be a full-body workout once per week. Others may prefer an upper and lower body split. Some may combine strength sessions with cardiovascular training throughout the week. The specific plan matters less than the long-term habit. And maybe that's the deepest lesson I've taken away from exploring this topic. At the beginning, we started with a mystery. Why are some people stronger than others, even when their muscles don't look dramatically different? The answer ultimately led us through an incredible biological story involving muscle fibers, motor units, neural pathways, and the remarkable adaptability of the human body. What fascinates me most is that strength is not simply something we build, it is something we teach. Every challenging repetition teaches the nervous system to communicate more efficiently. Every strength workout reminds powerful muscle fibers that they are still needed. Every session becomes a small investment in future capability, and perhaps true strength isn't measured by the weight on a barbell at all. Perhaps it's measured by the freedom to move confidently through life, the ability to remain independent as we age, and the resilience to meet whatever challenges the future brings. When I think about strength now, I no longer see muscles first. I see one of the most extraordinary partnerships in human biology, where the brain, the nervous system, and the muscles work together to create something far greater than any of them could achieve alone. Strength teaches us a lesson that goes far beyond fitness. What makes us stronger is not always what is most visible. Just as the nervous system quietly develops the ability to recruit more strength over time, many of life's greatest improvements happen beneath the surface through patience, consistency, and small daily efforts. Whether you're building physical strength, learning a new skill, or improving your health, progress often comes from repeatedly showing up rather than chasing quick results. Start where you are, stay consistent, and trust the process. The adaptations you cannot see today may become the strengths that define your future. Now I'd love to hear from you. What is one physical ability you want to maintain or improve as you get older? Please share your answer in the comments below so everyone can learn from different perspectives and experiences. And if you enjoyed this exploration of human biology and want to discover more fascinating science-based stories about the human body, aging, health, and performance, please consider subscribing to the channel. Your support helps motivate us to keep creating more thoughtful and educational content for future videos. Thank you for watching, and I'll see you in the next one.